So with that, I'll welcome our next speaker, Dr. Yanfei discussing the status of OpenFabrics interfaces support in MPICH. Yanfei holds an appointment as a computer scientist at Argonne National Laboratory. He's a member of the Programming Models and Runtime Systems Group and has been working on multiple software projects including MPI, YAXA, OSH MPI. He is a member of the IEEE and a member of the ACM. Please take it away.
Thanks, Phil. I realize I might need to restart WebEx to just get it, have the permission to share my screen. So I'll be right back.
Okay. Sorry for the delay. We'll hopefully be restarting in just a moment. Had a suggestion from Sean Hefty, who frequently speaks to this conference, to tell jokes. I don't know that I have any jokes prepared, Sean. Sorry. You could play us your kazoo. You're usually very talented at that. Ah, here we are. Yeah, you may be muted if you're speaking.
Yeah. Can everybody hear me? Yeah. See the slides?
Yes. Thank you.
Yeah. Thanks. So hi everyone. I'm Yanfei Guo. I'm a computer scientist at Argonne. I mainly work in the MPICH project. So this is some updates on our side. I'm going to talk about give you a rough background about what MPICH is and why we've been using OFI or LibFabric in MPI and some of our current status and future plans. So in case you don't know, MPICH is a high performance implementation. We're open source implementation of the MPICH standard, which is widely used in scientific application and on these large clusters. This has been a long journey for the MPICH project to evolve from the starting 30 years ago or so. So overall, we're using an approach that we're building what we call a MPICH ecosystem that we developed the open source MPICH library, which includes the support for the MPI standard and also general optimizations for large systems. But at the same time, we collaborate closely with our vendor providers to allow them to use the open source code for their own product. What usually happens is our vendor collaborators like Intel and Cray, they will take our open source code and apply their specific optimizations for their customer or target machines and ship their MPI library as a product. And at the same time, we also collaborate with a broader community of math library and tools library teams to have a better support and good user experience for the entire what we call the MPICH ecosystem. So MPICH has started to use LibFabric as the lower level network transport library since about almost 10 years ago now. That's quite a long time. So a lot of the challenge that we had back then is for the MPICH team, which is a small team at Argonne, to support all the different hardwares and different network hardwares efficiently and have a very good performance. It's simple, just impossible, right? This is not going to happen. So with LibFabric, what it provides us is it provides a layer that we can optimize on the generalized implementations of MPI communication as well, the vendors can contribute directly into the libfabric library, and by combining these two, we are able to get a good performance everywhere. And 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 also an important part that we benefit a lot from using libfabric is the socket provider, actually, because a lot of our development happens on our own laptop, and we need a provider that supports all the capability that we can test on to verify our day-to-day development. So here's just a rough overview of what MPICH today is like. Basically, we have a two-layer structure where on the top layer is machine-independent implementations of the MPI functionality, like such as collective and derived data type, and group management, including you creating the communicators, and all these are exposed to the application as the MPI interface. So below that, we have what we call the abstract device layer, where the current one is called CH4, which handles the actual data movement and more architecture dependent functionality rather than the general one. So libfabric is being used here to provide the transport over for networks. So right now we're on the MPICH 4.2 release series, and 4.2 has been released back in February this year. So here are some of the major changes that comes in this new version. A big part is the support for the recently rectified MPI 4.1 standard, which includes a few new functions and features. One of the most important one is this we call MPI memory kind. So this is basically allow user to indicate what kind of memory is being used and being operated in individual communication operations. So from the library perspective, it just allows us to have more information and apply optimization. For example, if we know that a communication is happening on a GPU memory, then internally it will allow MPI to bypass a lot of checks on where the buffer is, because we know it's on GPU, and we can directly route the traffic to the GPU optimized path communication through libfabric. So this is one good example of this. Apart from the supporting the new MPI standard, we have some new experiment features that we've been cooking in MPI. One of them is the what we call MPICH thread communicator, which I'll go into a little bit of detail after this. And also there's the MPI5, pending MPI5 ABI initiative. And lastly, we have generally tried to improve the GPU support, especially with the support of Intel GPU. This is in collaboration with our partners at Intel, and they have contributed a huge amount of codes into this improvements. So the interesting stuff that we've been doing in the past year or so is what we call a MPI thread communicator. So this is related to the MPI plus X hybrid program model. So traditionally, when you write MPI programs, you launch a bunch of processes on the node. Usually maybe one process per core, and you scale out to multiple nodes. But as more and more applications are trying to adopt multi-threaded program model like OpenMP, or maybe using peer thread directly if the developer feels that way, but that creates a huge challenge for migrating existing MPI applications to that hybrid model. Part of because the multi-threaded MPI communication usually runs into significant contentions in in the network layer because the different threads, they were trying to compete for the shared communication context. We had solutions to address that by basically mapping those traffic to different communication contexts under the hood. But again, the interface is not very suitable for some of the cases, which we to address that issue, we develop something called MPIX thread, not MPI plus thread. So this is using a what we call a thread communicator. So traditionally, a communicator only represents processes in your application. We extend that notion into covering all the threads instead of just processes. So in this case, you'll be able to create a special thread communicator that you can use directly in a OpenMP parallel region. And what under the hood is the library would understand whether a two thread is communicating on the same node or through different nodes. And if it's on the same node, the MPI send receive semantics will be essentially translated into a bunch of load stores into the implicitly shared memory region. And the off node traffic will be again mapped into the different communication contexts. So far, this has supported both blocking and non-blocking point-to-point communication, and also blocking collective, which should cover most of the use cases of MPI. So here's then the question is how does this perform comparing to traditional MPI process-only communication. So here we focus on the on-node part where the difference is the most significant. As you can see here, using the thread-com gives us significantly lower latency. This is mostly because we know that these traffics are on the same node and can map the data movement into a load store operation instead of go through the MPI semantics to actually do the send and receive. So that gives us some improvements in both the latency and the bandwidth on the same node. But the interesting is once we've been able to use a communicator inside a OpenMP parallel region, that opens a lot of new possibilities. For example, one of the example is the MPI collective, including MPI barrier here. So here is just a comparison between an MPI barrier and a simple OpenMP barrier. As you can see, if we, in our case, we implement an optimized version for the MPI barrier in here using atomics, which allows us to get the same level of performance as a simple OpenMP barrier in the power region. So which makes it simple for your application to scale in this way. And similarly, this is also another region that MPI has traditionally been performing well because MPI has many optimized collective algorithm available depending on your message size and how many process or threads in this case are going to communicate. So here's a comparison just using MPI reduce operation versus a OpenMP reduction operation. So as you can see, we'll be able to get a much better performance compared to the OpenMP reduction, thanks for the MPI's better algorithms. And we have one application, PATC library, trying to use the thread-com to scale the application into a hybrid program model. As you can see here, it's getting at least on par performance, and in some high thread count cases, it has some disadvantage. But overall, it's an easy migration for the library. And one more thing that I want to highlight is the support of the MPI5 ABI. So this is This is an ongoing effort at the MPI Forum, which traditionally MPI has a standardized API interface where you have MPI functions and everybody's calling to. But different MPI library will have different binary interface for these functions. As a result of that, when vendors, especially these cloud providers, are trying to provide pre-built softwares that uses MPI, it has to maintain different versions for the same library that interfaces with different MPI binary interface. So the MPI forum has come up and trying to address this problem by introducing a standardized binary interface that all the MPI library would eventually be providing. So we have this prototype implemented and released in the MPICH 4.2 already. Although this is not standardized, but what we provide is now MPICH would have two different API, two different binary interface. We have the traditional binary interface, so if your application is still relying on that, yeah, you still get access to that. But if you're building a new application that use MPI, there's option that you can use the new API. So in the future, once the API is standardized, your application you can build your application once and swap out different MPI libraries under the hood without breaking the application. So that's the 4.2 series. And upcoming in this year, we've been working on the 4.3 series. So the plan again is pushing out the alpha release in the second half of this year, and we're targeting for a SC24 release for the beta version, and final GA release will be early next year. And in the 4.3 series, there's we planned a few changes roughly in two categories. One is for standard related and quality of life improvements, if you would. So including the better support for the MPI sessions and also the support for dynamic library loading. So this applies to all the external library that MPICH relies on, including libfabric and CUDA and ROCm. And apart from this, another part of the work plan is for the performance and performance optimizations. This including a better support for a dynamic VCI allocation. So this would allows the MPI to better use the communication context that libfabric is providing by dynamically change how the context is assigned to different communicator and different threads. And we're planning to improve the performance of our data type handling engine, the Yakuza library. And in addition to that we are working on a overhaul of the existing collective architecture inside MPICH to have better support for topology-aware collectives and also be easier interfacing with external collective libraries such as the libfabric collectives and other library like, for example, Nickel, if you would. So here's the overview of what's going to happen in the 4.3 series, and if you have something that you're interested in or your application relies on, but it's not on the list, and can let us know, and we can see we can certainly include those. And lastly is just one research project we've been working on is related to the integration of lossy compression into the MPI collectives. So we have a tool called gZico, which is a compressed compression collective for MPI. So we've been able to using the GPU to do the compression and integrate the compression part deeply into the collective pipeline. So right now we're getting a significant boost in in the performance comparing to the Cray MPI and Nickel on on the Polaris machine that we have at Argonne. And the paper is accepted by ICS, so you'll hear more later this year about this work. But right now, I think I'll just overview should be fine. And that's everything I have for the MPICH side. And I'm happy to take any questions.
If there are any questions, please feel free to unmute your microphone and speak.
So I have a question about this MPI5. So you're now calling that the MPI5 ABI. So are you expecting anything like saying MPI5 standard in the future, or this goes to result for the ABI only?
The ABI is planned for MPI 5.0 standard. The 5.0 is not just ABI. It will have other things, but the the binary interface standardization is planned for a 5.0 version. Yes.
Okay, I see. Yeah, thanks.
Yeah, but if you're using the 4.2 version of MPICH, you should already have this functionality because it's not standardized. We don't promote them, let everyone like in the feature list, but it's something in there. The part is because the standard hasn't been ironed out with all the details, and there's still changes going to happen in this until it's actually being the standard being rectified and in the print. So
is there any way to like say identify at the runtime to see this library is conformant to this standard, or how to be negotiated out of the scope?
The query for the ABI standard is I think it's a good point to raise to the MPI forum. So right now MPICH you can run there's a binary with the MPICH distribution called MPICH version. It will show you the features that is supported in the MPICH library, but that is not standardized, unfortunately. And the standardized way for you to look at what MPI version is supported by the library is usually just looking to the MPIH MPI.h header file. So I think we'll have to find a better way to provide the checking on the ABI part, but that should be in the standard, I think, in my opinion.
Great, Hari, I see you have your hand up. Would you like to say something?
Thank you. Hi, Yanfei.
Hi, Hari.
Very nice talk. Could you go back to the slides about the compression?
Yeah.
Were you using lossy or lossless compression here?
This is a lossy compression.
Okay.
Yeah, we're using SZ. Well, actually SZX in this case.
Okay. Okay. And what was the application that you were using here? Was it a deep learning application or a traditional scientific application?
This is a traditional scientific application, image stacking, that kind of application.
Okay.
So we had a question from Seth a little while ago. I'm sorry, Seth, I missed it. The question was sockets versus TCP. I thought sockets were deprecated.
Sorry, can you repeat the question?
Seth, you feel free to unmute yourself, of course, if you'd like to ask the question better than I can. What I at about 9:51, which is 20 odd minutes ago, I heard him say sockets versus TCP. I thought sockets were deprecated.
Yeah, I think we're working on moving our test. This is mostly related to the our Jenkins test setup, right? Because that is relying on socket heavily. But I imagine there should be no problem switching that to TCP, because what socket provides is basic socket providers is saying that we support all the features in there. Because everything is software emulations, right? So I imagine if TCP do the same thing, we should it should be a painless migration to the TCP. But we haven't done that, I think.
Is that something that's in the plan, or is it just a thought right now?
I would say it's probably on back burner because it's mostly related to our own Jenkins testing. So if that is starting to, if one day that socket provider is removed, then or we'll do the migration. But we're kind of procrastinating on a little bit.
No, perfect answer. Thank you.
Yeah, do you have any like a specific feature that is in socket but not the in TCP? Do you have any information on that, or just because socket was more has more support?
I don't have a I probably should have done this comparing the socket provider and TCP, but I haven't. So I don't think we're relying on anything that's socket specific.
Mm-hmm.
Let's see. Is there any other questions? All right. Thank you. Thank you very much for that presentation. Appreciate that very much.
Right, thanks.